Okay, this is the second half of the video for section 4.2. Due to some technical difficulties, we'll say it got cut off of the first half. So this is number 6 in section 4.2. So it says we can gain some understanding of how the correlation coefficient measures association by examining the formula for its calculations. Note the calculations involved can be somewhat tedious to do by hand, so we typically use technology. And so the formula from your book is that the correlation, which is R, is equal to, we've got a summation sign here. Remember, we've seen that before for calculating the mean. And it says we're going to add up all of these products. And the products, if you look closely, are z-scores. So it says take the z-score for the x value and multiply it times the z-score for the y value. And then you're going to divide all of those by n minus 1. So I should include that summation sign here as well. All right, so for each point, so I'm just going to jump down to the scatter plot. If I take that point, I want to take the z-score of its x value, multiply it by the z-score of its y value, and then add it to the z-score of this point's x coordinate times the z-score of its y coordinate, and add those products and keep going until I do that for all the points in the graph, and then divide by n minus 1. All right, so we're going to use the following scatter plot to continue looking at this formula. So we're going to take a closer look at how the formula produces a positive correlation. So remember, positive correlation means that R is between 0 and 1, and it could also be equal to 1. All right, so let's continue on with that first point I took a look at. All right, so over here, if we look at it, right, what is its x value? Is it going to have a positive z-score or a negative z-score? Well, we need to know where it is in relationship to the mean of the x values. And that's what this vertical line here does. This is at x bar, x, the mean of the x values. This line here, this horizontal line, is at the mean of the y values. And so keeping those two in mind, we can then see that this point over here in blue has a z-score for x that's above 0, or positive z-score. So we're going to say that the z-score for x, I'm just going to use z with a subscript of x, is going to be greater than 0. It's going to be positive, and it's above average. The z-score of its y value, so if we look at where it is relative to the mean of the y values, notice that's above that horizontal line. So that means its z-score for its y value is also greater than 0. So remember, in our formula, we then multiply these two z-scores together. And so if we multiply a positive times a positive, we get a positive product. And in fact, what we'll notice is that the same will hold true for all of these points up here in this section of the graph. All of them are going to have positive products. If we go to this other section of the graph, so let's take a look at this point here. Its x value, or x coordinate, is below the mean. Notice it's to the left of that vertical line. So that means its z-score for the x coordinate is less than 0. It's below average. Look at where it is relative to the average of the y values. It's below that horizontal line. So its z-score for its y value is also going to be below 0 because it's below average. And in this case, if you multiply two negative numbers together, because that would be our next step, is to get its product, notice that we would get a positive product once again. Because a negative times a negative would give you a positive number. So these would be positive products. Remember over here, this was also a positive product. And again, if we look more closely at all of these points down here, they're positioned in similar ways, meaning that their products of their two z-scores are also going to be positive. So when we add all of these products together, it's going to keep making your sum larger and larger. It's going to get you closer and closer to a correlation of 1. And so it's going to keep your correlation positive. It's going to give you a positive correlation, and it's going to strengthen it because you're not detracting from it, as we'll see in the next example. Okay, so in the second one, we're going to use the scatter plot again to take a closer look at how this formula produces a weak correlation in this case. So I'm going to start over here in the top right. We just saw from above that the products of the two z-scores for the x coordinates and the y coordinates, they're both going to be 0, or sorry, greater than 0. So the products are going to be positive. Okay, and I'm going to do the same thing down here in the lower left because we just saw from above that those z-scores for the x and the y values, or x and y coordinates, were both going to be negative, below 0, which again gave you a product that was positive. Okay, but let's take a look at the other two areas of this graph, because we didn't do that yet. So I'm going to take this point down here on the lower right. Notice that its x-coordinate is above average. Again, that's compared to this vertical line here that's marked at the position of the mean of the x values. So its z-score for the x-coordinate is going to be greater than 0, because it's above average. If we look at its y-coordinate, which is below this horizontal line, which again is at the mean of the y values, it's below that line, so it has a z-score for its y-coordinate that's less than 0, because it's below average. So if you remember from your algebra days, you take a positive times a negative, you get a product. Clean that up just a little bit. You get a product that's negative. Okay. And that is going to be true of all of these points down here in this area of the graph. Okay, so we've got one more area to look at. Let's take this point as our next example. So we're in the top left. If you look at its x-coordinate, for that vertical line at x bar, so that means its z-score for the x value is below average, so it's negative. If you look at its y value or y-coordinate, it's above the horizontal line. It's above the average of the y values. So that means its z-score for the y-coordinate or y value is greater than 0. It's above average. And once again, we have a positive times a negative, which is going to give us a negative product. Right, so now what you can imagine happening, if you take all these products and you add them up, you're going to have some positives, some negatives, and they're going to start to cancel each other out. So if you add positives and negatives together, you're going to get a sum that's going to be closer to 0. So here, the sum of these products will be close to 0. And that means that your correlation, which is R, again, is going to be close to 0. It might be a little bit above, might be a little bit below, but it's going to keep it in the weaker range. And one reminder here. Okay, one reminder here, again, this formula is somewhat tedious, so it's not one that you're going to have to do by hand very often, if at all. It's really not one you have to memorize. So I want to open up StatCrunch right now and just show you how you can use that to calculate your correlation. Okay, so I've opened up section homework 4.1 and 4.2. I went to problem number 16. I think this was the first one I found where it asked you to calculate the correlation. So if it says find the correlation between these numbers or calculate the correlation, and you notice this icon up in the top right, you don't have to do this by hand. So if you click on that point there, you have to go to the computer to do that. I guess I'm going to have to get rid of that circle first. And if you click on that icon, you have a menu that pops up, and you want to say open in StatCrunch. And if you have pop-up issues like I do, you may have to click OK. So here's StatCrunch. The data has been transferred over. And what we want to do is go to Stat, Summary Stats, choose Correlation, and we want both variables. So I'm going to use the Shift key to get both variables in there, and then calculate or press Compute. And the correlation comes up. Doesn't use the symbol R, but we can supply that. This is R. And then check StatLab to see what the rounding instructions are. Okay. Again, this is the correlation that they're asking for. Right, so no need to do this by hand.